Hello, and welcome to The Space Above Us. Episode 107, Space Shuttle Flight 35, STS-41. Hang a left at Jupiter. Last time, we talked about the flight of Space Shuttle Discovery on STS-31. The crew of STS-31 deployed arguably the single most important shuttle payload of the entire program, the Hubble Space Telescope. We mostly focused on challenges of the deploy itself, rather than digging into how Hubble worked. But don't worry, we'll be seeing plenty of the Hubble Space Telescope in the episodes to come. Part of the reason for that has less to do with how Hubble worked, and more with how it didn't work. Any new spacecraft goes through a period of commissioning after arriving on orbit. Its flight characteristics, onboard systems, and sensors would all have been known quantities for years. But now that it was actually in space, it was time to learn how the thing really flew, and make sure that everything was working okay. In the case of science instruments like the Hubble, they also need to go through a calibration period. Since Hubble is a telescope, that meant taking pictures and making fine adjustments to the position of the large mirror, getting everything into focus. The thing was, they just couldn't quite get it to go. The optics folks looking at the data would have seen what sure looked a whole lot like classic spherical aberration, indicating an incorrectly shaped mirror. But that can't be right. Hubble's mirror had been carefully polished for years, conforming to exact specifications. But did it? We're going to save all the nitty-gritty details for a future episode, but the fact was that the Hubble Space Telescope, NASA's multi-billion-dollar crown jewel, had blurry vision. This was devastating news to those who had worked on Hubble and the long list of scientists lining up to use its data. All was not completely lost, however. Hubble could not take clear pictures, but it was still above the atmosphere, allowing it to perform spectroscopy of ultraviolet light sources, something impossible on the ground. By breaking down the UV light, all sorts of valuable and interesting data could be gleaned from the ailing telescope. And this wasn't some consolation prize. It was real science that had been planned all along. Hubble's schedulers simply moved more spectroscopy observations forward and moved planned imagery later. But that didn't stop Hubble's issues from becoming a public relations fiasco. A telescope that can't take pictures? What was NASA even doing over there? Not helping with NASA's PR woes was a series of technical problems out at the shuttle launch pad that summer. The next flight after Hubble, STS-35, was supposed to launch in late May, but after an impossible-to-track-down gaseous hydrogen leak in the aft compartment, it had to be rolled back to the VAB on June 15th. With Columbia back in the shop, attention turned to Atlantis for STS-38, but just 2 days after the Hubble announcement, on June 29th, a hydrogen test on Atlantis resulted in a similar leak. After spending July trying to fix the leaky spacecraft, Atlantis 2 was rolled back to the VAB on August 9th. After 2 rollbacks, Discovery was back on the docket, this time for STS-41. With a busted telescope and a summer of hydrogen leaks, could STS-41 end the streak of bad news and nail a narrow launch window in October? The launch window was tight, only open from October 5th to October 23rd, because of a noteworthy payload making the ride uphill in Discovery's payload bay, Ulysses, the last interplanetary probe to be deployed by the Space Shuttle. Originally called the International Solar Polar Mission, which I think has a nice ring to it, the mission was later renamed Ulysses, after the adventuring hero of Homer's Odyssey. And oh, what an adventure it would have. This joint venture between NASA and the European Space Agency would be going where no spacecraft had gone before, exploring the region above and below the Sun. But wait, above and below? We're going to space. There's no up and down in space. This is true, but it also means that we can define our own up and down. When we measure where stuff is in the solar system, one of the points of reference we use is the plane traced out as the Earth makes its way around the Sun, called the plane of the ecliptic. So when I say above and below, what I really mean is above and below the plane of the ecliptic. What made Ulysses unique was that it would be studying the Sun from far below and far above the plane of the ecliptic, where no other spacecraft had ever been. Spacecraft tend to stay near the plane of the ecliptic since that's where all the interesting stuff like planets are, and because it takes a ton of energy to tilt an orbit relative to the plane. It's the same reason why it's hard to take a spacecraft in an equatorial orbit and tilt it into a polar orbit. Inclination changes are just expensive. But with a cleverly planned trajectory passing close to Jupiter, it was possible to twist Ulysses' orbit and place it nearly perpendicular to the planets. This would allow the spacecraft to study the polar regions of the sun. Is the environment different there? Does the solar wind change? Are there fewer or more charged particles? A suite of instruments and antennae would find out. Ulysses was originally supposed to launch in 1983 using a Shuttle Centaur upper stage. Delays eventually pushed it into 1986, and after the Challenger accident, it had to be reworked with a new upper stage. We'll talk about that a little later. If Discovery couldn't get off the pad in its 18-day launch window, Ulysses would have to wait another 13 months for the next launch opportunity. And after 7 extra years of waiting, I'm sure the folks working on the project were eager to get things underway. As were the 5 people we'll be talking about next. Commanding the flight is someone we saw not too long ago, Dick Richards. Richards was the pilot on STS-41 just a few flights back. His theory was that since he had to wait over 9 years for his first flight, he was being rewarded with a pretty quick second flight. And he's just getting started since this was his second of 4 flights. Joining Richards up front was our pilot and future director of the Kennedy Space Center, Bob Cabana. Robert Cabana was born in Minneapolis, Minnesota, and also mysteriously has his birthday missing from his official biography. He attended the U.S. Naval Academy, picking up a degree in mathematics, before heading down to flight training in Florida. He spent a while flying A-6 intruders around, was a project officer for the X-29, and was a test pilot, focusing on ordnance separation testing for the A-6 and A-4. Cabana was especially excited to be flying with Dick Richards as his commander, since pilots learn a lot from their commander, and Richards learned from Brewster Shaw, who learned from the one and only John Young. Also, since this wouldn't fit in anywhere else in the episode, I wanted to mention that while reading his oral history, Cabana was asked, "Would you volunteer for Mars 1?" referring to the short-lived plan to send people on a one-way trip to Mars and fund it by making the whole thing a reality TV show. Cabana responded, "No, that's dumb." He was selected as an astronaut in 1985, and this is his first of 4 flights. Mission Specialist 1 was Bruce Melnick. Continuing our streak of strange birthdays in the official biography, NASA only lists Melnick's birth year, 1949. Melnick attended the U.S. Coast Guard Academy and then spent the next 20 years in the Coast Guard, where he was heavily involved in the development of the HH-65 helicopter, including literally writing the flight manual. He was the astronaut office's representative during the assembly and checkout of Space Shuttle Endeavour, who we'll be meeting a little bit down the road. This was his first of 2 flights. Sitting in the center of the flight deck was Mission Specialist 2, Bill Shepard. We know Shepard from his flight on STS-27 aboard Atlantis, which landed with significant damage after being straked by debris from an SRB nose cap. This is Shepard's second of 4 flights. And last but not least, Tom Akers. Thomas Akers isn't scared to share his birthday and was born on May 20th, 1951 in St. Louis, Missouri. He earned a bachelor's and a master's degree in applied mathematics, serving as a national park ranger during part of his time in school. Moving on from park ranger, he became a high school principal for 4 years before joining the Air Force and working as an air-to-air missile data analyst. So his career is pretty interesting. He was flying the F-4, F-15, and T-38 when he was selected as an astronaut in 1987. This is his first of 4 flights. It's interesting to note that this is a pretty green crew. Out of 5 crew members, they only had 2 space flights under their collective belts at the start of the mission. In an oral history interview, Bob Cabana bemoaned how tough it is to be a new astronaut. You're introduced as an astronaut, and people immediately ask you if you've been to space. Well, no, not yet. Oh. Once you have been to space, they ask how many times. You say just once. Oh. Then once you've flown a few times, they ask if you've been to the moon. Nope. Oh. Just no winning with some people. Commander Richards commented that he felt an important part of his role as commander was teaching the newbies the little things about spaceflight that you might not figure out on your own or find in the training manuals. For instance, most of the training is not done in the cumbersome pressure suits actually worn on the shuttle. So he would encourage Cabana to practice hitting switches without turning his head very much, even using small mirrors to help spot hard-to-reach switches. I wonder if that tip came to us down the commander lineage from John Young. Or I guess taking it one step further, from Young's commanders, Tom Stafford and Gus Grissom. When October 6, 1990 rolled around, the Kennedy Space Center had not seen a shuttle launch since April 24th. It had been too long. The weather report looked slightly iffy, but everything else was good to go. Discovery had already been checked for hydrogen leaks and had come through with no problems. Pilot Bob Cabana recounts that he was nervous at the prospect of getting space sick on the flight, so he stuck to coffee and an English muffin for breakfast. Mission Specialist Bruce Melnick, on the other hand, had steak, eggs, home fries, and hot sauce. Commander Richards commented that Melnick seemed to be going for both color and distance. Luckily for everyone involved, Melnick was not added to the list of those susceptible to space adaptation syndrome. After suiting up, the crew boarded the Astrovan for the short ride to the launch pad. As is tradition, the head of the astronaut office joined them for the ride. In this case, it was LDEF Retrieval Mission Commander Dan Brandenstein. During the drive, Richards prompted Brandenstein, "Aren't you going to lead us in the astronaut's prayer?" Brandenstein says, "Oh, yes, I'm sorry. Everybody take a knee." So they all took a knee and lowered their heads, and Brandenstein takes a moment and says, "Lord help you if you screw this up." Gotta keep the crew loose. As the crew tried to get comfortable resting on their backs in the spacecraft, the countdown continued smoothly. The liftoff time came and went, with intermittent rain to the north holding them at the pad for a few extra minutes. Once the rain drifted away, there was just one more problem. At T-minus 31 seconds, the system responsible for maintaining a stable environment in the payload bay began to act up. To protect the sensitive electronics aboard Ulysses, and probably something to do with the radioisotope thermoelectric generator, the payload bay was flooded with nitrogen gas. But the system that did this was going on the fritz. Ground controllers began to scramble in an attempt to fix the problem. Instead, the launch director pointed out that in 31 seconds, there would no longer be a need to purge the payload bay. Can they last that long? Oh, right. Good to go. On October 6, 1990, at 7:47 a.m., after a delay of a little over 10 minutes, Discovery lifted off for the 11th time. OV-103 had to put in some work, since when it arrived in orbit, it had delivered the heaviest payload of the shuttle program to date, at 49,969 pounds. However, I would be remiss if I didn't point out that STS-41L's payload topped the scale at over 52,000 pounds. But I think it's understandable that the STS-41 crew didn't count that towards their record. As the main engine shut down, Commander Richards called out, "Welcome to space." The external tank was jettisoned and Discovery fired its primary attitude control thrusters to scoot away. The 800-pound thrusters were so loud and caused the orbiter structure to shake so much that mission specialist Tom Akers, down on the middeck with no window, thought they had crashed back into the tank. Once everyone had a moment to acclimate to their new disorienting environment, it was time to get to work and start on the deploy sequence. Rather than a shuttle Centaur, Ulysses would be following Magellan and Galileo and riding an inertial upper stage. However, it needed even more power than that, so on top of the IUS was a PAM-S kickstage. The PAM-S seems to be pretty much like a PAM-D that we're familiar with, but a different model. Ulysses was going to be moving fast once all of its stages fired. So fast that it would cross the orbit of the moon in only 8 hours. As Tom Akers prepares for the deploy, let's take a peek out of the payload bay windows and see what we can see. Perched atop its pile of upper stages was the Ulysses spacecraft. Like many spacecraft, Ulysses essentially looked like a big gold foil wrapped box with some weird stuff sticking out of it. In this case, the box was about 10.5 feet long, 11 feet wide, and 7 feet tall. On top was a large high-gain antenna measuring 5.5 feet across. That's about 3.3 meters on a side and 1.6 meter antenna. Sticking out of the side of the spacecraft was a radioisotope thermal electric generator, an RTG. This again is basically just a tube full of magic hot rocks. I mean sophisticated radioactive fuel pellets. Since Ulysses would be flying out past Jupiter and spending the rest of its life a few 100 million miles from the sun, it couldn't get by with solar panels. Instead, it used the heat from the RTG to generate electricity. I guess with all the thrust coming out of the upper stages and with the heavy RTG sticking out of the side, it needed a little extra support. So somewhat hilariously, at least to me, there's a little metal girder that sticks out of the top of the upper stage just to hold the RTG. Well, it looks like while we were admiring Ulysses, Tom Akers finished his preparations. IUS cradle tilted up, comm checks run, deploy window coming up, and 3, 2, 1, off it goes. 6 hours, 1 minute, and 42 seconds into the flight, Ulysses was on its way to Jupiter. 38,604 pounds drifted out of the payload bay, all to get the 807-pound spacecraft moving very, very fast. Ulysses may have passed the moon in 8 hours, but it had to wait a bit longer to reach Jupiter, not swinging by the gas giant until February of 1992. By carefully angling its approach, the Ulysses ground team ensured that Jupiter would hurl the spacecraft quote-unquote down as it passed. A couple of years later, in May of 1994, Ulysses began its first 4-month observation of a polar region of the Sun, peering at the Sun's south pole from around 300 million kilometers away. In February of 1995, it crossed the plane of the ecliptic, and soon after that started a 4-month observation of the North Pole. The original mission was only through the end of September of 1995, but since the spacecraft and hardware were still healthy, the mission continued on. It wasn't until June of 2009 that Ulysses finally shut down after numerous passes above and below the Sun. The scientific results of this mission are a bit out of the scope of this episode and out of my depth, but as the only spacecraft to study the Sun from a highly inclined orbit to date, Ulysses ensured its place in the textbooks. Meanwhile, back on Discovery, the mission continued on. The flight was only scheduled to last 4 days, but there was plenty to do. As you'll recall from the last episode, mission specialist Steve Hawley had a difficult time manhandling the remote manipulator system and Hubble Space Telescope into going where he wanted, due to some noisy electric circuits. What I didn't mention was that he also had to juggle another set of controls to switch between 5 cameras in the payload bay, but only 2 displays to view them. Since situational awareness was so important, and since many tasks made crew members wish they had an extra set of hands to operate controls, NASA decided to give them one. Sort of. Mission specialists Bruce Melnick and Bill Shepard popped on some headsets and tried out the voice command system. With this, the crew could simply say out loud what they wanted the computer to do, choosing from a preset list of commands. This would allow a mission specialist to keep their hands on the RMS controls and still switch from camera to camera, simply by verbally requesting it. At first, the system had a little trouble. On the ground, the system understood Shepard's commands about 95% of the time. But on Discovery's flight deck, that number dropped to 62%. Was audio behaving differently in space? Nah, more probably it was just a different amount of background noise. Shepard and Melnick retrained the system on the fly with fresh audio samples, and command recognition was soon back near 100%. The verdict? Pretty useful system, but they wanted the ability to combine multiple commands into one in order to move things along a little bit faster. Still pretty neat. Another mini-experiment sought to answer the question, how do you point at specific things on a computer screen in space? On the ground, the world has pretty much settled on either capacitive touchscreens or a computer mouse. But since this is 1990, no capacitive touchscreens were available, and mice were problematic since they would drift away from the desk. Since future space station crews would need a reliable way to operate a computer, the STS-41 crew tried out a couple of different options. One was a trackball built into what seems to be the first, or at least one of the first, personal computers ever launched into space, a Macintosh Portable. Portable is a relative term here. Imagine the chunkiest, most beige laptop you've ever seen. Now make it twice as thick as you imagined, shrink down the screen, and wedge a trackball into it. Now imagine it weighs 15 pounds. Portable. No word on what the crew thought of the trackball, but I will note a suspicious absence of trackballs in photos taken aboard the International Space Station. Ulysses wasn't the only item of note in the payload bay. Flying for its second time was the Shuttle Solar Backscatter Ultraviolet Instrument, or SSBUV for short. SSBUV, again, is a set of instruments that can carefully measure how UV light interacts with the upper atmosphere. From this, scientists can determine how much ozone is up there. By doing this at the same time as uncrewed satellites in orbit, SSBUV could help calibrate their measurements. And since it came back with the shuttle, they could study how it was affected by space, tune it, and send it back up again. Hey, just like they just did. We last saw SSBUV on STS-34, and this is not the last we've seen of this Goddard Space Flight Center managed experiment. Lastly is a simple little experiment that's just a bit of foreshadowing for a future mission. The commercial satellite Intelsat 6 had a bit of a problem on its way to the geostationary ring, finding itself trapped in low Earth orbit. NASA was considering a rescue mission for the poor little guy, but since it wasn't designed for an extended stay in LEO, some questions had to be answered. One problematic aspect of the LEO environment is the presence of atomic oxygen. The oxygen you're used to is O2, two oxygen atoms stuck together in a molecule. When an oxygen atom is on its own, it really hates it. So when some hapless spacecraft minding its own business comes flying by and bumps into the atomic oxygen, it reacts. This reaction can be damaging to a lot of different materials, literally eroding it away. There was concern about how Intelsat 6's solar arrays would handle the presence of atomic oxygen. So in a sort of mini LDEF, an SDEF if you will, a sample of the solar array material was stuck to the end of the robot arm. The arm was then swung out of the payload bay and into the wind, so to speak, where it stayed for a full day, allowing engineers to study how it held up when it returned to Earth. I don't know what their findings were, but I do know that we'll be seeing Intelsat 6 up close and personal just a few episodes down the line. STS-41 was a pretty short mission, so just as the crew were settling in, it was time to suit up and come home. In an oral history interview, Commander Richards talked about how different commanders had slightly different techniques for handling the orbiter during landing. He was proud that his technique seemed to be popular with commanders that followed him. Richards preferred to bring the orbiter down to about 5 feet, and then take advantage of the ground effect caused by the large wings interacting with the air just over the runway. This created a cushioning effect, which would then gently bring the shuttle down the rest of the way, resulting in a nice, consistent, soft landing. You wouldn't break any records for the softest possible landing, but you would ensure that the vehicle and crew got home safely. Richards added, quote, "This thing flies very well without pilot inputs. It just occasionally needs to be guided. So just guide it, don't fly it." Well, guided, flown, or whatever, Discovery touched down after 4 days, 2 hours, 10 minutes, and 4 seconds, taking its place as the most senior member of the orbiter fleet, at least by mission count. Next time, we'll dig a little deeper into that hydrogen leak issue and learn what kept people all over NASA pulling their hair out over the summer of 1990. We'll also figure out what we can learn about the shuttle's last fully classified Department of Defense flight. Ad Astra. Catch you on the next pass.